Coleman, what question did you have?
How do we make numbers that always, when divided, have a remainder of 1?
Okay. Now give me a very specific question, like I gave you, find a number that cannot be evenly divided by 2 or by 3. Mm-hmm. Or maybe I should have said that has a remainder of 1 when divided by 2 and has a remainder of 1 when divided by 3. What would be the next question?
Which number has a remainder of 1 when divided by any prime?
Well, but you're trying to jump. Wait, Coleman, wait. You're jumping to the whole. You're trying to answer the whole big question. When you say any prime and da 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 da. No, I'm talking very simple and very concrete. The question I asked was, I wanted a number which, when you divided by 2, you got a remainder of 1, and when you divided by 3, you got a remainder of 1. So I want the next, even completely trivial extension of that. Don't try to generalize it. I want actual numbers. I don't want, talking about all primes and things. What would be a very specific question?
What about 2 times 3 times 5?
Okay. So what kind of a number you're trying to produce?
Is which number has a remainder of 1 when divided by 2, mm-hmm. and by 3, mm-hmm. and by 5.
Excellent. Okay. And how could you produce a number which, when you divide it by 2, you get a remainder of 1, when you divide by 3, you get a remainder of 1, and when you divide by 5, you get a remainder of 1?
You can multiply 2, mm-hmm. and 3, and 5, and add 1 to that product.
Okay.
And that is 31.
31? Okay, so this is a number which you have produced. Now, let me ask you this. Why didn't you ask the question, well, what's a number which has a remainder of 1 when divided by 1, by 2, or by 2, by 3, or by 4? Why did you skip 4?
4 is already a product of 2 and 2.
Okay.
And so that question would be, which number has a remainder of 1 when divided by 2 and 2 and 2 and 3?
I see. And you didn't want to do that? Why not?
I think it's equally as interesting.
Okay. But you could have done that.
Yes.
You could have just said, what's a number which, when divided by 2, by 3, or by 4, mm-hmm. has a remainder of 1? And what would that number be, by the way?
2 and 3 and 4.
Mm-hmm.
6 times 4 is 24. Plus 1 is 25.
Right.
25.
Right. But the better way to think of it is 2 times 3 times 4 plus 1.
Yes.
Because that illustrates where it came from, what your strategy was.
Yes.
When you combine them, then it doesn't help you anymore. You don't see where it came from.
Yes.
Okay, very good. Okay, now let me ask you this. Let's now see if you see a pattern here.
Okay.
First of all, do you see a pattern here?
I don't.
Okay, so let me ask you another question. Can you find a number which, when divided by 2, by 3, by 4, by 5, by 6, by 7, by 8, by 9, by 10, all the way up to 1,000, no matter what one of those numbers you divide into it, you get a remainder of 1?
It's always one more.
So, yeah, it's a remainder of 1. So you divide, the number you're going to describe for me mm-hmm. has the property that if you divide it by 2, you get a remainder of 1. Mm-hmm. If you divide it by 3, you get a remainder of 1. You divide it by 4, you get a remainder of 1. You divide by 5, you get a remainder of 1. By 6, by 7, by 8, all the way up, 997, 998, 999, 1,000. Any one of those numbers that you divide into it, you get a remainder of 1. Can you describe a number with that property? So that's the challenge for you all. Can you think of a number, natural number, which when you divide it by any natural number 2 up to 1,000, like 57, you divide 57, you get a remainder of 1. how would you describe such a number?